Today we're looking at section 7.1, solving linear systems by graphing. We have a couple of goals: solving a system of linear equations using graphing and also using it to model a real life problem. Beginning on page 398. We have a couple of definitions first. First one is, what is a system of linear equations? Notice it's two or more linear equations in the same variables form, or they form a system, I should say, of linear equations, or simply a linear system. So two or more equations, such as y equals x plus 2 and y equals 1/2 x minus 3, that's a system of linear equations. We could graph both of those on the same plane, which we'll do looking at our second definition, a solution of it. You graph two equations on the same plane, and where they intersect, if we had a plane that looked like this, where the red line in this case and the blue line intersect, this is the solution, the point where they cross. That's the only point that when you plug the value in, it makes both equations true. So solutions of a system is two variables x and y in an ordered pair. And we would name that point, we would name it as x comma y, whatever those values happen to be. Using graph paper, again, helps tremendously on this. And we have small graphs provided on the sheets that you use, and I have a worksheet in a minute. We're going to do the same thing. Okay, we have a few steps in order to solve it. The first thing is to write the equation in a form that's easy to graph. For most of us, the form that's easy to graph is slope-intercept, y equals mx plus b, because it tells us where to begin and it tells us where to move. So if something's in standard form, ax plus by equals c, go ahead and move it on into slope-intercept form. The second thing is step is to graph both of them in the same coordinate plane. We're not going to graph them separately, but we're going to graph them together. That way, when they intersect, it'll show us the point that makes both of them true. Number 3 is to estimate the coordinates of the point of intersection. For the ones that we'll start with, for sure, it'll be a whole lot easier. They'll be integers. We won't deal with fractions, or we won't deal with decimal numbers. But you're going to pick the point that they both cross through. It's going to help you tremendously when you're graphing these equations on these graphs if you use some kind of a straight line to do it. Don't just freehand it. Because if you freehand it, it's a little less likely that you'll intersect correctly. And then the last step, go ahead and plug those two values you get in for x comma y. Remember, it's going to give you an ordered pair, x comma y. Plug those values into the two equations that you originally had and see if you get true statements, just like the Bell word. Example number 1 is using the graph and check method. We have two equations. Notice both of them are in standard form. Ax plus by equals c. That's not as friendly when it comes to graphing. So the first step you're going to want to do is you're going to want to move them into something that's a little bit easier to graph, like slope-intercept form, or y equals mx plus b. So we have 5x plus 4 equals plus 4y equals negative 12. First thing you want to do is you want to get rid of positive 5x by subtracting 5x. If you do it to the left side, you have to subtract 5x from the right side. Remember, you can't take 5x away from negative 12 because they're not like terms. So all we can do is write them next to each other. The next step you want to do is you want to get rid of 4 times y by dividing by 4. If you divide the left side, make sure you divide the right side by 4. And notice you divide both terms, the negative 5x and the negative 12. You're left with y equals negative 5 over 4x minus 3. That is mx plus b. And notice your slope, or your m value, is negative 5 over 4. And your b, or your y-intercept value, is negative 3. Do the same thing with the second equation. You have 3x minus 4y equals negative 20. Get rid of positive 3x or plus 3x by subtracting it. If you do it to the left side, make sure you do likewise to the right side. Remember, you can't take 3x away from negative 20 because they're not like terms. One of them has a variable and the other does not. Then get rid of negative 4 times y by dividing by negative 4. If you do it to the left side, make sure you do it to the right side as well. You're left with y equals 3 over 4 because a negative 3 divided by negative 4 is a positive 3 over 4. And then negative 20 divided by negative 4 is a positive 5. So mx plus b. So your slope value in this case is 3 over 4. And your y-intercept in this case, your b value, is 5. So we have two equations that are much easier to graph. Take those two equations and then graph them on the same plane. Graph them on the same plane, like so. Begin with -3. So our first point will begin -3. Our slope tells us to go down 5 and to the right 4 times. Remember, in this equation or in this picture as you're looking at it, it's hard to go down 5 and to the right 4 times. You can do the reverse of that and go up 5 and to the left 4 times. So up 5 and to the left 4 times. Up 1, 2, 3, 4, 5, and to the left 1, 2, 3, 4. There's your second point, and that's how you can draw a straight line through that first equation. Your second equation, y equals 3/4 x plus 5, your b value is 5, so you begin at +5. Your slope tells you to go up 3 and to the right 4 times. Again, if we go up 3, we're going to run off of our picture. So up 3 and to the right 4 times is the same thing as down 3 and to the left 4 times. We had an example like that a couple of weeks ago. So down 1, 2, 3, and to the right 1, 2, 3, 4 times. Our second point, likewise for our first equation, is at that same point. So we would draw our second line going through there. They intersect at that point. Then you want to estimate that that point, in this case, you can see that that point's value is -4, 2. Remember, because you go to its x value first, and then comma y value. So -4, 2. Then you want to plug those values in for both x and y to see if they give you true statements. If we plug it into equation number 1, we're going to bring in, again, this is x and this is y. So 5 times not x, but -4, plus 4 times not y, but 2. 5 times -4 gives you -20. 4 times 2 gives you 8. -20 plus 8 is -12. This is a true statement. Notice -12 is equal to -12. The second equation, as you look at it, you're plugging in, again, x comma y, -4, +2. So 3 times -4 is -12, and -4 times 2 is -8. -12 minus 8 gives you -20. This is a true statement as well. It says because -4, 2 is a solution of the linear system, of each equation, then it is a solution of the linear system. You would present your answer as -4, 2, written as an ordered pair. Here's your checkpoint. Notice the first set of equations is not in a graphing friendly form. So you want to convert 3x minus 4y equals 4 and x plus 2y equals 8 into slope-intercept form. You would subtract 3x on both sides and be left with -4y equals -3x plus 4. Divide by -4 on both sides, and you would have y equals a +3/4x minus 1. So that equation is much more friendly to graph. Let's go ahead and make our second equation more friendly to graph as well. Subtract x on both sides, and you're left with 2y equals -x +8 or plus 8. Get rid of 2 times y by dividing 2, and y equals -1/2 x plus 4. Now, both of those are much easier to graph. mx plus b, where 3/4 and -1 are your values, and -1/2 and 4 are your values. Graph each of those equations. The first one, begin at -1 here. Go up 3 and to the right 4 times. 1, 2, 3, and to the right 4 times. There's your second point there. You draw a line through there. Your second equation tells you to begin at +4. And it tells you to go down 1 and to the right 2 times. So down 1 and to the right 2 times. There's your second point. You draw a straight line through both of those. The place where they both intersect, or the point where they both intersect, is there. That point is 4, 2. So you're going to take 4, 2 and plug them back in. Most of us can mentally plug in 4 and 2 and see if we get a true statement or not. Some of us need to write it out. A lot of us probably have to write it out. 3 times 4 is 12, minus 4 times 2 is 8, And 12 minus 8 is 4. So 4 equals 4. This one checks out. The other one, plug in 4 and 2 again. This is 4, and this is 2. 4 plus 2 times 2 is 4. 8 does equal 8. That one checks out as well. That's what it means by graph and check, because you have to plug them in to check to see that they both work. So if you come up with something and it doesn't work, then you messed up something along with your math, your arithmetic. Move these into a much more graphing friendly form. Move 5x over for the first one. It becomes 2y equals negative 5x positive 4 or plus 4. Get rid of 2 times y by dividing 2. Y equals negative 5 over 2x plus 2, mx plus b. Move your second equation likewise. Get rid of negative x, move it over. You're left with 2y equals negative 9x plus 12. And divide by 2 to get rid of 2 times y. And y equals negative 9 over 2x plus 6. So you have two equations that are much more graph friendly. The first one, your b value is 2, so you begin at 2. It tells you to go down 5 and to the right 2 times. 1, 2, 3, 4, 5, and to the right 2 times. There's your second point. Your second equation tells you to begin at 6. It'll be off the graph about right there, unfortunately. Tells us to go down 9 times and to the right 2 times. So down 9 and to the right 2 times happens to be the same point as the last one we drew. Where they're going to intersect is at that point 2, negative 3. You can see 2, negative 3. Plug those in to see if they give you true statements or not. 2 and negative 3. 5 times 2 is 10. Plus 2 times negative 3, so it'll be 10 minus 6 is 4. 4 does equal 4. You can do the same thing plugging in 2 and negative 3 here. 9 times 2 is 18, plus 2 times negative 3. 18 minus 6 does give you 12, and 12 equals 12. Graph both on the same plane. The point they intersect is your correct answer. Your first equation here is in slope-intercept form already. All we have to do is move the second one into a more graph-friendly form. Move 2x over, you're left with 5y equals negative 2x on this side, positive 25. Get rid of 5 times y by dividing by 5, and y equals negative 2 over 5x, plus 25 divided by 5 is 5, mx plus b. Your first equation, y equals negative 2x minus 3. This is your m value. This is your b. B tells you to begin at negative 3. This is not a very friendly graph to what we're using. Negative 3 will actually be down here. The picture is not good. The one that I gave you guys actually fits it a whole lot better, I believe. But negative 3 tells us to go down 2 and to the right 1 time, or up 2 and to the left 1 time. So up 1, 2, and to the left point would actually be there. So that's what our first equation would look like, the one that's drawn. The second equation, the one that we just moved, would begin, B tells you to begin at 5 and to go down 2 and to the right 5 times. Or maybe you can go up 2 and to the left 5 times. So up 2 and to the left 5 times for your second point. The point they both intersect, or the solution of the equation, is here, negative 5, 7. When you plug in negative 5 and 7 in the first equation, 7 is your y, negative 5 is your x. Remember to put them in the correct spot. 7 equals negative 5 times negative 2 is a positive 10. 10 minus 3 is 7, so that's a true statement. Negative 5, 7 will plug in here as well. 2 times negative 5 is negative 10, plus 5 times y, or 5 times 7 in this case, is 35. 25 does equal 25. And then the last one, the first one is already in graph-friendly form, y equals mx plus b. We have to move the second one over. Move 7x over, you're left with negative 3y equals negative 7x when it moves over, and it's leave negative 6 alone. Get rid of negative 3 times something by dividing by negative 3. Y equals negative divided by negative will be a positive 7 over 3x, and a negative divided by negative will be a positive 2. So your first equation says y equals mx plus b. We'll go ahead and graph that one in. begin at 4, and again, y'all picture is a little bit better than mine, but you begin at 4, tells you to go up 3 and to the right once or down 3 and to the left once. Down 3 and to the left, that's where your second point would be. Your second equation, your M value tells you where to move. Your B value tells you where to begin. Begin at positive 2, and you can go up 3 and to the right once or down 3 and to the left. I'm sorry, down 7 and to the left 3 times. So down 7 and to the left 1, 2, 3 times for your second point. It's a little harder to see where they intersect since they kind of are a lot sharper. But the point that I just highlighted in blue is the point that they're going to intersect at. Your M value or your X value is -3, your Y value is 5. When you plug both of those values in, you see if it's a true statement or not. -5 in place of Y, 3 times -3 is -9. -9 plus 4 is -5. This one's a true statement. Check the other one as well. Plug in -3 in place of X and -5 in place of Y. 7 times -3 is -21. And negative times a negative will give you a positive 15. -21 plus 15 is -6. That one is true as well.